Okay, and the session is getting recorded. So I have to repeat this entire whatever we have talked, so don't mind. So today we are going to talk about the meteorological conditions, the MET. So meteorological condition is very important to understand for any aviator before flying the aircraft or before getting the aircraft into the air. Just ping the screen so that it is visible. So there might be a lot of changes in the atmospheric conditions or in the weather. So this is very important for an aviator to understand, to prepare the flight plan and also to get into the air. So that is why the study of meteorology is very important. So if you look into the definition of meteorology, so meteorology is the study of atmosphere and weather processes that occur. And why is it important? As I told you, so aircraft is flown in air, and the changes in the atmosphere may affect the the flight performance or the flying of an aircraft. So that is why we need to understand the meteorological conditions. And the meteorology is the science which deals with the study of atmosphere, and an aircraft is designed to fly through this medium. So various weather processes and the changes that occurs in atmosphere has great significance for aviation. And also these meteorological forecasts and observations form an integral part of flight planning for safe execution of flight. So as I told you, the meteorological department provide all the necessary information for the air crew or to the aviator or to the pilot to prepare the flight plan so that they can fly in the safe zone. It means the meteorological conditions like thunderstorms, snowstorms, heavy rain, low visibility, high temperature, dense fog, all these areas can be avoided for the safe flight. And after that, there will be following to that, there will be a MET department presence. The aviator undergoes a presentation by meteorological department to understand in much more detail, followed by flight plan. So if you look into the information which provides us, then World Met Organization is one. Under that, we have the Indian Meteorological Department and International Civil Aviation Organization. So Indian Meteorological Department provides all the necessary information related to India and the surroundings of India, the weather conditions, the changes in the weather conditions. So if you visit to the site, that is imd.gov.in, there you can see the images on daily basis which are captured through satellites, maybe indigenous satellites, INSAT, or the radar images, or also you can see the combined images of satellites and the radar. So here the weather is basically a change in the atmospheric condition, and this range from say few centimeters to thousands of kilometers. So as I told you, if within a radius of say 1 kilometer, if it is raining, then if we go to another place after 1 more kilometer, the situation might be different. It may not be raining. So that we call it as the weather. So let me take you to this Indian Meteorological Department website and show you some data. Now hope you can see the screen, the entire screen I have shared. I expect the senior cadets to stay with me.
Yes, sir.
Okay. So when we visit to the website of IMD, Indian Meteorological Department, so that is imd.gov.in, so that is also called as MOSM website, mosm.imd. So when we visit here, we can see all the meteorological information that is provided. So here there is a satellite image. So if I click to the satellite images here, so I can see the various satellite images captured by different camera. Means they may use infrared camera, then a visible range camera, and all these. So with this image, whatever you are seeing here, so this is captured from the infrared camera for the Asia sector, and this is the visible range, and you can see there is a slight clouds here and the water vapors like this. So you can explore this, and if you want to see the entire globe, then again the globe is again pointing towards India, so, but still it covers maybe the surroundings of India, and we can see some animated motion of infrared, the few images which are captured through infrared camera, and then this is the visible range. We have to use the satellites use the different bandwidth cameras to capture the different information. Okay, if we take the spectral band, then the different spectral band provides a different information. So that is why in satellites we use different types of camera, maybe thermal imaging camera or infrared camera. So it depends on the purpose, for what purpose we use. So for vegetation, we may use a thermal camera to understand the vegetation. So there is also an app, if you are interested, you can download. So I'll just go through this video.
India Meteorological Department, Ministry of Earth Sciences, has taken various initiatives
audible?
in recent years for improvement in the dissemination of weather forecast and warning services based on the latest tools and technology. To further enhance this initiative, Ministry of Earth Sciences feels proud to launch the mobile app MOSA for India Meteorological Department. This mobile app is dedicated to the general public and designed to communicate the weather information and forecasts in a user manner without technical jargon. Users can access observed weather, forecasts, radar images, and be proactively warned of impending weather events. The MOSA mobile app has the following 5 services. 1. Current weather, which provides the current temperature, humidity, wind speed, and direction for 200 cities, updated 8 times a day. Information on sunrise, sunset, and moonrise, moonset are also given. 2. Nowcast gives 3-hourly warnings of localized weather phenomena and their intensity issued for about 800 stations and districts of India by state meteorological centers of IMD. In case of severe weather, its impact is also included in the warning. 3. City Forecast provides the past 24 hours and the 7-day forecast of weather conditions around 450 cities in India. 4. Warnings, where alerts issued twice a day for all districts for the next 5 days in color code, red, orange, and yellow, to warn citizens of approaching dangerous weather. The color code red is the most severe category, urging authorities to take action. Orange code prompts authorities and the public to be alert, and yellow code prompts authorities and public to keep themselves updated. 5. Radar Products provides the latest station-wise radar products updated every 10 minutes. The MOSA mobile app will be an important tool for dissemination of weather information and warnings in an attractive and user-friendly manner, which will meet the requirements of the public. The mobile app has been designed and developed jointly by ICRISAT's Digital Agriculture and Youth Team, Indian Institute of Tropical Meteorology, Pune, and the India Meteorological Department.
Okay, so that app you can download from anywhere, maybe in the place. I think it's there in the Play Store also. So first you need to understand this weather forecast, and if you see the radar images, so this is the radar image, and we can select any region here, and then we can see the radar images of that and animation for last 3 hours that we can understand. So that needs a little understanding to understand the radar images. Anyway, otherwise all other information is there. So I have explored few more things. The rainfall information is very interesting. So when you go to rainfall information here, so then we can zoom in to any district we want. So if we see here, so let's take Dakshin Kannada. So this is Dakshin Kannada district. So you can see the data as well. I have seen the data. I am not sure. Day wise, Karnataka, and say somewhere here. I've seen some information. I want to show you that. Subdivision. Okay. Rainfall statistics. Yeah. So this is of interest, which I find because you're all engineers and you're all studying the, the machine learning and other things. So you can use this data basically, which is provided in the website, and you can select the state-wise data, or you can go for uh, district week by week data. So this is a very huge data. You can download this data, convert this to Excel, and you can use some machine learning algorithms, and you can do some kind of predictions and for different regions. So this is how where exactly the engineers play a role. Okay, you just learn programming and maybe Python or machine learning, but then what you're doing, so you can use this kind of the actual information which is there. So likewise, you can use district-wise, even day-wise data is there, which is very huge data, day-wise data, actual, normal. You can use all this information, and week-wise data is there, yearly data is there. So you see, collect all this information and you try to do some kind of, interpretations. So that will give the actual meaning for all your activities, what you're doing, what you're studying, right? So I just wanted to show this website. So I hope you all can install this app and at least study what is the meteorological conditions, how the weather is changing, and all those things. So this you can install even in your mobile apps, or you can visit this site, which is very informative. Okay. Now let us coming back to our presentation. So the briefing of meteorological condition, as I told before, so that is done to the crew uh, before going into air, or after the flight plan is prepared. So it is called as the mass net briefing in Air Force. So mass net briefing is done by the meteorological department. So when the briefing is done for a large body of people. So MET briefing always precedes the flight plan, as I told you, and the cooperation between the MET section and the air crew are essential to maintain a high standards of accuracy in forecast weathers. So what is that in the briefing that is mentioned, or the silent features? So in this mass net briefing, so the silent features, so meteorological officer may present all this to the pilots. That is the silent features observed during latest weather charts. So maybe in past 24 hours, what are the variations that has happened in the weather, so that will be presented. And what is the present weather situations at the base. So basically, the aircraft when it is flying or when it is at the ground. Basically, when we talk about, say, there is aircraft here. So this is the airbase. This is the aircraft, and assume this is the airbase. So one thing is that the meteorological conditions here need to be studied, and also wherever these aircraft fly and pass through, even that region meteorological conditions need to be studied. So all these information has to be provided by the meteorological department, and that is presented in the mass net briefing. And also the forecast of for the base and for next 6 to 12 hours, because when the aircraft is flying, so it should know even what is the forecast, what is the predicted. It is not the actual, it may not be actually happening thing, but it's a predicted based on various algorithms that based on the past history, it is predicted that the weather conditions may going to be like this or like that, whatever. So that is for the base and divisionary airfields. So now, what is the difference between the climate and the weather? So that is very important to understand for us. So weather, as I told you, it is the continuous change in the atmosphere. So as you have seen in that image which I have shown, the satellite image, the clouds are continuously moving. So that is the change in the weather. Climate means it is studied for a longer duration of the period. So when we talk about the climate, so climate, the climatical changes or something like this. So when we talk about the global warming, that is the climatical changes. If we talk about monsoon season, that is the climatical changes, or winter season, it's a climatical changes. So over a long period of time, whereas weather is a continuous changing process. Okay. So weather is described in terms of instantaneous value or a short period mean value of the net elements. So from the definition of climatology, the elements studied are the same as in the weather, but it is for several days or months or years or centuries. So far, if you have any queries, you can ask. Any doubts?
No doubt, sir.
No, sir.
Okay. Okay, then we are good to go. We'll proceed. Next, we'll study about the atmosphere. So what is there in the atmosphere? So atmosphere consists of gas or air. So basically the air composition varies. There are different kinds of airs, the composition of air that forms the composite, the different types of gases composites with air. So that we will see here. Basically, an atmosphere consists of, say, a nitrogen of 78.09%, an oxygen of 20.95%, argon of 0.93%, and carbon dioxide of 0.03%. I expect all the cadets to note down these values because this will come in your examination. Okay. So 99% of the atmosphere is occupied by the nitrogen, and nitrogen and oxygen. So in that 99%, there is a 3 part of it is the nitrogen and 1 part is the oxygen. So have you all noted? So nitrogen is 78.09%, oxygen is 20.95%, argon 0.93%, carbon dioxide is 0.03%. So atmosphere cannot be or never be completely dry. So there will always a water particles or water vapor exist in the air. And these water vapors can be in the form of solid, liquid or gases. And along with these water vapors, so there will be a small minute particles that we call it as a suspended particles like dust, smoke, all these are maybe mixed together, impurities, and this will affect the transparency of the atmosphere. It means the visibility of the atmosphere, it may not be as visible, or it may reduce the visibility with these small suspended particles like dust and smoke. So if we talk about the layers of atmosphere, then there are different layers. Before going to that layers, so let us understand that as we go higher and higher in the altitude, the pressure and density decreases. So this should be very, very clear. So if I consider this is the Earth's surface here, then the air particles here are densely packed like this near the ground, near the Earth's surface. As we go higher in the altitude, then what happens? Air particles are get separated like this. So as we go high and high, so what happens? The pressure and the density decrease. So that is what the pressure and density decreases as we increase, as we go above the Earth's surface. So as we go higher in the altitude. And this will also affect in the temperature. So there is, as we go higher in the altitude, there is also a change in the temperature. And due to this, there might be a tendency for the atmosphere to be divided into several spheres. It means what we have done. So due to these variations in the pressure, density, and also in the change in temperature, the atmosphere is split into various layers. So the first layer is the troposphere. This is up to 11 to 16 kilometers from the Earth's surface. Next is the stratosphere. It is up to 50 kilometers above the Earth's surface. Then mesosphere, 50 to 85 kilometers, and thermosphere, that is above 85 kilometers. So again, this will come in your examination, the atmospheric layers. Note down, and also the altitude from the Earth surface is also important. So note it down. So first one is troposphere. Its altitude is from 11 to 16 kilometers. Stratosphere up to 50 kilometers. Mesosphere 50 to 85, and thermosphere is above 85 kilometers. Now, if you look into this graph, it's very interesting to see. This graph is the temperature versus altitude. So here the y-axis is the altitude in terms of kilometers, and x-axis is the variation in the temperature, that is both positive as well as the negative temperature. So as you see in the troposphere, which is very close to the Earth's surface here, which is from the Earth's surface with an altitude of say 8 kilometers to 16 kilometers somewhere. So as we go higher in the altitude from the Earth's surface in the troposphere, so we'll be in the troposphere layer. So then the temperature starts decreasing. The temperature starts decreasing in the troposphere as we go higher and higher. And to a certain extent from troposphere, if you see the tropopause is the region between the troposphere and the stratosphere, where if we further go higher in the altitude, the temperature remains constant. And then at this point, again, if we go higher in the altitude in the stratosphere, the temperature may remain constant or it may increase slightly. And again, the tropopause, in the stratopause, the temperature remains constant with the altitude. But again, in the mesosphere, as we go higher, again, there is a drop in temperature. And mesopause, again, the temperature is constant with respect to the altitude. And in the thermosphere, what happens is that the temperature is almost like a linear, it increases with respect to height. This is a very simple diagram and you can easily remember. You start with the troposphere with negative temperature, then go to stratosphere with positive temperature and mesosphere with negative temperature. It's just like a zigzag and it's very easy to remember. So I expect all the cadets to remember this graph because it might be important at some point of time. Now, this we already seen from the graph. The troposphere is the nearest layer to the Earth's surface. And most of the atmospheric conditions that happens, the rain, formation of clouds, All these things happens in this troposphere. That is why the troposphere is very important for us to understand and study. And in this, as I told you, as we go higher in the troposphere, the temperature starts decreasing. And what is the lapse rate? Lapse rate means at what rate the temperature drops. So that is a 6.5 degree per kilometer or 1.98 degrees per 1,000 feet. Now, stratosphere is the next layer of the tropopause, which is extended to 50 kilometers. That we already seen and we have discussed it. And the temperature may be constant or steady, or it may increase with the height. The mesosphere, again, above the stratosphere is the mesosphere, and here the temperature again decreases with the height. Next, thermosphere is again the temperature increases with the height of the altitude. And this is the outermost layer of atmosphere. And here the gravitation pull of the atmosphere is almost like practically absent. So most of the lower Earth orbit satellites and medium Earth satellites will be in this thermosphere layer, or at an altitude of 400 to say 700 kilometers. So most of the satellites are placed like lower Earth, LEO and MEO satellites are placed in these altitude. One of the lower part of this thermosphere is a highly ionized state. It means the particles in the ionization, it means either it might be positive or negative ion formation is there. So due to which there is a very strong layer is formed, and that layer we call it as the ionosphere. And this ionosphere helps in the radio communication for a longer distance. So what happens when the radio waves are transmitted? When the long waves, when the radio waves are transmitted, it gets reflected from this ionosphere and it reaches the other part on the surface or in the air. And few even very low frequency, what happens? It will pass through this, ionization layer, and it travels into the space. So that is why this RF communication is possible for a longer distance, and this is like hopping. So the frequency again gets reflected from the Earth's surface and again reflected from the ionospheric layer, and we can reach a very large distance of communication. But the problem with this communication is that, so as you can see, if you want to reach somewhere at this point, may not be possible because the atmosphere conditions, the atmospheric condition, the ionosphere is not constant. It changes over the day, over the time. So the reflections, due to which the reflection may reach to the far distant or may reach to the near distance. So communication but still happens with these radio. So the different frequencies has to be changed accordingly. Now let us talk about the international standard of atmospheric conditions. So this is very much important for aviation to have some standard, because throughout the world, throughout the aircrafts, the ATCs, all these need to follow some standards of these atmospheric conditions, the readings and all these things. So that is why this international standard has been adopted. And that is defined by ICAO, that is International Civil Aviation Organization, and which is known as for meteorological conditions, it is the International Standard Atmospheric Conditions. And as per the International Standard Atmospheric Conditions, again this will come in your examination, note down these points. So as per ISA, International Standard Atmosphere, the mean sea level temperature is 15 degrees, mean sea level pressure is 1013.25 millibar, surface density is 1225 G per meters cube, that is a gram per meter cube. Acceleration due to gravity is 9.8 meters per second square, and the rate of fall of temperature is, that we already seen, the 6.5 degrees or 1.98 degrees per 1,000 feet. Hope you have noted these points, because this will come in your examination, B and C certificate examination. The international standard atmospheric may come like fill in the blanks. What is the mean sea level temperature as per ISA? So it should be 15 degrees. What is the mean sea level pressure? What is the surface density? All these things. So the atmospheric pressure at any level in the atmosphere is referred to the weight of the column of air or unit cross section. So air has the weight, and as we have discussed before, the pressure and the density of air decreases as we go higher in the altitude. And here the atmospheric pressure decreases with height, and the rate of decrease of atmospheric pressure is 1 millibar for every 30 feet of height. So as we go 1 millibar, 30 feet higher, so 1 millibar pressure is reduced. So the standard notation of pressure is millibar or psi, pounds per square inch, or mm of Hg. Okay. If you have any queries, you can ask. We will stop at this point, and then further meteorology we will study in the coming classes from the coming session. So any queries so far?
No, sir.
No, sir.
Okay. If there are no queries, then we'll wind up our session at this point. Anything else related to NCC or anything that you want to put across? Okay. There's nothing then.